Okay, so the other day we learned about isotopes and average atomic masses, and today we are going to talk about ions. And it happens to be an ACP schedule, so things are going to go a little quickly today. So, some things to review, to think about. Protons are always having a positive charge. They are located in the nucleus of the atom, and that's important to remember. Neutrons have no charge, and they are located in the nucleus of the atom as well, whereas electrons have a negative charge, and they're located in energy levels outside or around the nucleus. So those are some things that you need to keep track of and remember. Other things that we have to review. We spent some time talking about what happens if we change the number of protons. And if we change the number of protons, we change the atomic number of the atom. And if we change the atomic number of the atom then changes. Our example in the notes the other day was carbon, and then you added a proton, became nitrogen. And then when we change the number of neutrons in an atom, what ends up happening is the mass number changes, and you get a different isotope of the same atom. So we changed carbon by adding or taking away neutrons, but it was still carbon. Now, the new thing that we need to focus on today is what happens when we change the number of electrons around the nucleus of the atom, or outside the nucleus of the atom. So, what happens when we change the number of neutrons, or electrons rather? We create a new structure called an ion. An ion is an atom that has gained or lost electrons and has a charge. So, because it has a charge, and because it can either gain or lose electrons, the charge can be positive or negative, and it kind of depends on what happens to the atom itself. So, let's take a look at an arbitrary made-up atom, and let's kind of identify what's going to go on here. So, let's see. The positive thing is clearly in the nucleus, is clearly a proton. And when I'm looking at this first particular structure on the left-hand side here, I see that there is one proton. I also see that in terms of neutrons, which I didn't put on here and forgot, there happens to be one neutron. I also see that there are 2 negative things, so those are 2 electrons. And when I identify the charge here, if I'm going to identify the charge of the atom, it's basically the difference of protons to electrons. So in this case, I see that I have a +1. Let's do some different color. A +1 plus a -2, because remember there's 2 negative things. So the charge then becomes, in this case, a -1. Okay? Now, in the case of the second one, I'm going to go back to the second middle atom. I see that I have 1 proton. I see that my neutrons are also equal to 1, and I see that I have 1 electron. So when I'm going to assess charge here, I'm going to take my +1 plus my -1, and that's going to give me a charge of 0. So this would be considered a neutral atom. And then the third one, all the way on the right-hand side, I see that I have 1 proton, and I have 1 neutron, and I see that an electron has left the energy level, so I'm going to say that there are 0 electrons. So now what I'm going to do when I assess charge is I'm going to take my +1 minus the number of electrons, which in this case, 0, because it left, and that gives me a charge of +1. So the general format for identifying the charge of an atom is what happens to the electrons. So if I'm looking at an atom and I want to identify charge, I would say that I would take my protons, and remember that they have to be positive, minus my electrons, and that has to be negative, and that should give me the charge. And it's either going to be positive, negative, or zero if it's a neutral atom. So all of the time that we've been talking about this, I've always been saying, like, until I tell you further, or when I tell you it differently, like, you should assume it's a neutral atom. Well, from this point forward, you cannot assume it's a neutral atom because we now have this ability to identify what type of, if there's an ion present or not. As an example, we have this is the way notation will be written for this, where we'd have the element symbol, the atomic mass, the atomic number, and then also the charge. So if we remember the atomic mass or mass number is equal to protons plus neutrons in the nucleus of the atom. So that's our atomic mass business. Now, the atomic number is simply equal to the number of protons in the nucleus of the atom. And now our charge is going to be based on the number of electrons. Around the nucleus of the atom. So here's an example that we can work through. So we have the element over here. We have this notation. Mass number will be 7, and the atomic number will be 3, and I'm going to tell you that it has a charge of +2, or not +2, that's silly, +1. So, first thing we can identify here, from the periodic table, this element, Li, is lithium. The next thing that I can identify is the mass number. And I know my mass number is my atomic mass, so that's going to be 7. The next thing I can identify is my atomic number. And I see from this setup that the atomic number is equal to 3. So now, let's get down to the nitty-gritty here. Protons, neutrons, which we've been doing all unit, and electrons. And now we're going to add the new thing, which is charge. Okay, so protons. The atomic number tells me the number of protons, so in this case, it's going to be 3. And I see that this element has a charge, so the electrons we're going to have to figure out in a second. So the next thing that we're going to do is we're going to take a look at neutrons. Well, we know that neutrons is equal to mass number minus protons. So in this case, the mass number is 7 minus the protons, which is 3. So the number of neutrons in this case is going to be 4. Now, let's go take a look at this charge. So we can identify from the location of the notation behind the elemental symbol that the charge is a +1. So in order for us to have a charge of +1, and based on the formula that we had before, which we said that charge is equal to protons minus electrons. So now what I'm going to do is I'm going to move this formula around just a little bit to use the charge to go ahead and figure out the number of electrons. So if I look at the formula, charge is equal to protons plus electrons is really what it should be. It should be plus, that's silly. Protons plus electrons. What will end up happening is that in the case of this example, I know that I have a charge of +1, and I have the number of protons to be 3, and I'm trying to figure out the number of electrons. And so what I'm going to do is I'm going to subtract 3 from both sides. And when I subtract 3 from both sides, I get a value of -2 for my electrons. So that tells me that I have 2 electrons in this particular atom, or ion, rather. And the same thing works if we have a negative charge. So an arbitrary atom would be something like, let's see, charge is equal to protons plus electrons. Okay, so if I said that I had something like an ion with a charge of -2, and the number of protons were 6, and I was trying to decide how many electrons I had, I would subtract 6 to both sides, and I would get a value of -8, which is 8 negative things, which is the number of electrons. So that's how you identify charge. Now, your homework this evening is a two-sider, and as a result of it being a two-sider, what ends up happening is that part of it you're going to answer a couple of questions, you might do some drawings, and then you're also going to go ahead and lastly, you're going to go ahead and be filling in a chart. That's either you're going to be given something that looks like this and have to figure out the protons, neutrons, and electrons, or you're going to get the other parts, the protons, neutrons, and electrons, and come up with this notation. Good luck, and we'll check it in tomorrow.